Okay, today we're looking at a situation where we have two main population parameters, how much money someone makes, okay, and whether they smoke or not, each one having 3 different levels. Okay, and we're trying to determine, is there a relationship here or not? Okay, so I ask you to draw a picture of this situation that maybe best describes to see if there's a difference or not. Open up your books to page 760. I hope yours looks like that. I'm looking around and I see quite a few like that. And some of you just did it on one axis and did the 3 different groupings. That's fine. But basically they said, okay, let's look at people that don't make a lot of money. Let's look at their smoking rates. Look at people in the middle and look at people in the high. Now, if income had no difference at all, then the people in the low income would all have the same smoking rates. People in the high income would have all the same smoking rates. Okay, so you want to draw a picture that highlights that one way or another. Now, I'm looking at these, and I'm seeing that people that don't make as much money have a higher smoking rate. And I've seen people that make a lot of money have a lower smoking rate. Okay, so we definitely do see some differences here from the pictures. Remember, that's just from a sample. Okay, so the question is can we infer that on the entire population based on those sample sizes? So that's our challenge today. Okay, we just talked about how to enter that stuff into the calculator. Let's go ahead and do that right now. Let's use our happy button to find out what these values will be. Obviously, we're going to use them later in calculation. But if you didn't quite get that the first time, let's do this together now. Okay, so let's go into the matrix. I'm going to edit the first one. And this is going to be a 3 by 3. Okay, and you'll see that the matrix sets itself up perfectly for that. All right, let's put in our observed counts. So 51, 92, 68, 22, 43, 28, 22. Okay, going to do the chi-square test on that data. And we skip ahead right to the final answer, right? Our chi-squared for this problem is going to be 18.5. P-value's tiny. Okay, so we can already write our conclusion. We know what it's going to be. Hey, if income level has nothing to do with whether you smoke or not, this is impossible almost. You're not going to get something like this. And let's go back and remember our key definitions for independent or dependent. If something is independent, if you know something ahead of time, it doesn't affect the next thing. If something is dependent, if I know something happens, it does affect the next thing. This is saying that these are dependent. If I know someone doesn't make a lot of money, does that change the probabilities of whether they smoke or not? Based on this, the answer is yes. All right, so let's talk about how we do the full hypothesis test for a problem like this. All right, population parameter. Let's just go with this, just to kind of define what we've got going on here. Probability, we'll go I and smoking, something like the true percentages of smoking and income level. Just kind of, I mean, we have 9 different probabilities over here. So let's just net them out. One line, population parameter. It's the true proportion of smoking rate and income level. Okay, our null and alternate change a little bit here. We're not setting a whole bunch of probabilities equal to each other. What we're just going to say here is that something like we're going to assume that there is no relationship between them at all. If I know someone's income level, it doesn't affect anything in terms of whether they smoke or not. So one way to say this is smoking and income level, or income, are independent. Smoking rates don't change. How much money you make, that's what we're going to assume. Nothing's going on here, nothing to see. All those graphs we put together would have kind of the same probability. Another way you might see this is there is no relationship. You might see it written that way as well. There is no relationship between smoking and income level. The alternate, what we're trying to prove is, no, if I know one of these things, how much money they make, it changes. I know something about what the smoking rate's going to be. So, smoking and income are dependent. You might also see this written as there's a relationship between smoking and how much money you make. Nothing changes here. Whatever threshold you want to use, we're making a type 1 mistake. Nothing changes here. Was it a good sample taken? Are our expected values all greater than 1 and at least 80% greater than 5? Nothing changes here. Okay, these are the same three formulas we're going to use. And over here, you're going to draw the big old box. Okay, you've got your happy button. So you're going to be able to put all those expected values in there. Make sure you just write down your row and column totals. You're going to be able to write the chi-squared, show 3 of them, show this one, and the last one. Happy button gives you that chi-squared. Draw your picture and write your conclusion. Nothing changes what we've been doing. Conclusion for this one, assuming that smoking levels and income levels are independent, there's almost no chance of getting a distribution like the one we got. Since our p-value is lower than our alpha level, you write those down. We do have statistically significant evidence to say there is a relationship between income level and smoking. And don't forget, somebody, third period, said, well, wait a minute, does that say that it causes it? No, remember you have to do a good randomized controlled experiment. We get it caused. There could be some lurking variables here. I mean, we could do the experiment on cavity level and reading, okay, and we'd get a statistically significant evidence, right? So we don't get caused. We'd actually have to randomly pick people, say they can't earn any money, and these people really earn money, and then do the test and see if it works. Okay, but we can find a relationship. Something's going on here. Knowing one influences the other. Okay? Questions, comments? Okay, okay.